Guys, morning. Found something that was quite shocking to me, and I would suggest that you go down here to the far right and click that box so you get the full screen. But I pulled up the ISWA runs for the magnetosphere on these Z cut, which looks straight down on the planet from north to south. Y cut, which looks straight across the planet, sort of an equatorial view, they call it. And of course, this is the magnetopause. These are the Earth radii. That's what that stands for, RE. Okay, here's what I want to focus on. Solar wind speed, velocity, 1,372. Huh? I've never, ever seen it that high. And it's never, ever supposed to be that high. Solar wind from the sun averages, and I looked it up, and since my video time's limited and so is yours, I'm sure, averages between 400 kilometers a second and 700 kilometers a second, not 1,372 kilometers a second. So the assumption that I made on the last video where I said it had an epiphany, which didn't occur till toward the end of that video, and according to YouTube, I only got about 64 views on that video, which quite surprising, being that I had like 16 or 1800 on the one just 2 days prior. So I don't know if they're playing with the numbers or you guys get tired of me or what. But here's the deal. 1372 wind speed. This is all being measured by these GOES satellites that come around the Earth in a geosynchronous orbit. So they're going around. So they might be in different positions at different times. I'm not sure exactly which one. I think it's the GOES 13 maybe that does this modeling. The data from, or they could probably be getting it from all of them, as far as I know. But anyway, the point being, these measurements are coming from inside the magnetopause. And as you can see here, we had definitely had some type of an event occurred. Okay, there's the 1372. Now here's the arrows. That shows you which way the solar wind pressure is pointing. But look, well, of course it's nemesis solar wind pressure. I don't know. Or that's our magnetosphere pressing it out, or that's the overload and the plasma being rejected. That's why these arrows are going this way and that way. But we have some that are pointing this way, coming in toward the Earth, as you can see. So, and we got a lot of plasma buildup in front of the Earth, which is inside the magnetopause. So this has all got to be coming from some type of a solar body back here. And like I contended before, I think it's up on this region somewhere. But anyway, there we go, 1372. That was yesterday at the UTC 2149. And then you see the big discharge. You still got arrows going this way. So we still got some pressure coming in from the back. And look, these two are pointing this way, these three. Even though there's being a big plasma discharge and it's all going out. And look how the arrows all start to come back. So there's definitely something pushing. And then I guess the plasma builds up. And at some point, fortunately, the Earth's magnetosphere is able to repel it. But I don't know how long that's going to last. So watch these arrows. They kind of tell the tale, in my opinion. Now that was the highest. Now look, you can see here we had some type of an event there. That was at 137 UT. But anyway, let's go and look at ACE. So here's the solar wind at 2149, which was when we had that huge 1372 reading. Look, they have an increment that's way down to 10 now. That's how low the solar wind speed is, being measured at the ACE satellite, which is at the L1 Lagrange point, 930,000 miles in front of the sun, in front of the Earth, between the Earth and the sun. And then once it picks back up again, you can see it's all over the board. So my hypothesis would be that the solar wind pressure coming from Nemesis is in the electromagnetics is messing with the solar wind speed being recorded on ACE. That would be my one observation. Oh, that's the geospace. Okay. Well, here's another one. This is another satellite they put up, the Discover satellite. That's supposed to replace ACE at some point, but it's supposed to be at the same spot at the L1 Lagrange point. So these readings should all pretty much conform to ACE, and I was looking at them and they pretty much do. But here you get, actually, if you drag your cursor, you can get the actual wind speed. So we can actually go, and there's not as much of a gap on this one. So I don't understand that. So obviously the gap's not occurring because of some type of a planetary body or something on ACE. Why there's an 8-hour gap, I'm not sure. Honestly, because this satellite's supposed to be up around the same spot, and we still have a gap though, from around 0300, a little bit before 0300 to a little bit before 0500, 2-hour gap. Maybe there's some type of recharge thing going on, or I don't know. Maybe since this is a newer satellite, it's got less of a gap than ACE. But anyway, here we go back to the 2149 point. That's when we had that big 1372 reading on the ISWA, and you could see that solar wind's all very low in the 300 range, 300 plus range, close to 400 throughout the run. And the solar wind density, that didn't really fluctuate too much either. So whatever occurred did not occur as a result of the sun. But then you see this. Now this is something coming from in front of the magnetopause being measured. And while you're clocking it at 681, keep in mind though that these numbers are all being clocked by these satellites that are going around Earth in the geosynchronous orbit. So, I mean, they're clocking stuff inside the magnetopause too, but I mean, this is representing some kind of a big solar wind pressure coming in at 133. So if you look at 133, do we have 133? No, okay, so yeah, there's 133. So this is good. This new satellite, we get to look inside the ACE gap. So at 133, whoops, I don't know what happened there. Guess I shouldn't have clicked it. So anyway, I pulled it back up. So 133, when we're seeing that something coming and hitting the Earth, well, so it's got to give it a little bit of a lag time there. They say 15 minutes to an hour, I think, between where the ACE is, Discover, out at the L1 point to where Earth is. That's how much of a warning we get, according to their mission statement. And you can see the solar wind, it didn't really fluctuate at all. So that also leads me to believe that something else is out there producing these density spikes or these velocity spikes showing up in front of the unless it's just being fooled by all this stuff going on in here. That's certainly possible. Pulled up the geospace. It's hard to read this actually, but I'll put the links. But you can see you got to flip-flop these because the ISWA one has the sun on the other side. But if look at all the solar wind pressure coming in behind the Earth, much greater than what's coming in front of the Earth. Look at that. That's a lot of pressure. It's some scary pressure. I'll put the links below so you can go in and check the stuff out for yourself. I really spent a lot of time this morning trying to figure out what the heck. So I pulled up some other stuff, and this is the ISWA Enlul, E-N-U-L. This shows the sun, there's the Earth, there's the key up here, and these are some of the satellites marked. There's stereo A and stereo B. B behind A. That's the L4 or 5 Lagrange point. The L4 or 5, I forget. But it'll be in that tutorial. I'll post it underneath in the description box. You can look up the Lagrange points. But anyway, what I noticed here, I've never seen this like smoke ring halo effect coming off the sun. And the sun's really not doing a whole lot right now. So how they're figuring that this big, looks like a CME, is coming off the sun, leaving today, and hitting Earth about late 10-2 or early 10-3. So I don't know. Keep an eye on that. I haven't seen anybody mention any projected CME impacts or anything coming up to the Earth, but clearly this computer simulation is showing something's going on. So these are the IMF field lines I was mentioning. You can see them streaming off the sun. And these are the connections to the different planets, and they even have them connected to some satellites. I'm not positive on that. But anyway, here it is here on the, there's that huge 2149. That was where we had the 1372 wind speed. Like you can see, it knocked a hole back here. And this is right before the huge buildup and discharge. So, I mean, we got some scary stuff going on around the planet. No doubt. And I've never seen a solar wind speed go to 1372. That's just crazy numbers. If that continues or it continues to get worse, and that's not good. Here it is here, 2149. You can see the pressure building behind the planet. Then the pressure gets real strong, I noticed that we get the square box effect around the Earth. For some reason, the computer just squares everything off. But watch the magnetopause. Look how it's being compressed. Normally it's out here about 10 Earth radii. And I showed you the ACE and the Discover data coming from the sun. There's no solar wind pressure, no solar wind speed that would justify the magnetopause being slammed like that down toward the Earth. Unless it's being weakened from behind, and then that little solar wind pressure is pushing it in. Maybe it's a weakening effect too. That's certainly possible. But I spent a lot of time trying to figure this out, and I couldn't. So anyway, the phone's ringing. God bless. I'm running out of time anyway. Peace out.